The purpose of this lesson is to learn about the semantics of C#, what a variable is and how it is used in C#, what variable types we have that we can use, what instance variables are, how to use class and static variables and local variables, different data types, variable casing when we type them out in the syntax of our program, how to declare and use variables, how to assign values to a variable, and the namespace. C# is what's known as a strongly typed programming language. What this means is that in some programming languages that are loosely typed, we can create a variable and we can put text into that variable, and then later on we can treat it like a number, and then later on we can treat it like text again. In C# that doesn't happen. What we do in C# is we declare a variable. We have to specify what type of data it is, and then once we declare it as that type of data, it cannot change. It's going to stay the same. So if I declare something as being a text string or something as being a number, then throughout the life of the program, that particular item has to remain as a letter or a string or a number. We are going to create lines of code, and at the end of every line of code we're going to put a semicolon. And what that tells the system is that everything that preceded that semicolon was one statement. And one statement is just simply all the stuff that makes up one particular command. So I want it to perform a task. At the end of that task I put a semicolon. Now some of the things that we're going to do, we're going to put inside of curly brackets, and those are what's called a container object. So if I'm doing things like a loop, or if I declare a class object, I have to put those inside of curly brackets to specify that those lines of code belong together. Once we declare a variable, we cannot change its data type. It has to stay the same. Alright, so what is a variable? A variable is nothing more than a named space in memory. In our old programming languages, we didn't have variables. What we would actually have to do is reference a memory location, and then we would have a memory range, so a beginning point and then an ending point, or in some languages we'd have to state that it begins at a certain spot and then it was so many bytes in length. Well, in C# we have variables, and a variable, like I said, is just simply a named space in memory. So what I do is I give it a name, and then we put some sort of value in that location, and then we let the operating system or the programming language actually manage that spot for us. So I don't have to worry about where the value is located. I just simply have to remember what the name of it is. So in this case here, it's easier to reference something like my variable name than it is to reference this range of memory locations. Now a variable can contain a value, and the value is going to be something like a text string like Bob, or a number like 35. The value of a variable can change throughout the life of the program, but we have to declare the variable before we can actually use them. What that means is I have to tell the system that I'm going to create a new variable that is an integer data type. Here's the name of it, and then I'm going to give it some initial value, something like maybe 0 or 6 or something like that. But what I have to do is I actually have to state that that variable exists before I can try to use it later in the program. Some of the programs that we're going to be using, we actually have to provide some initial value also. So if it's something like a number, I typically want to give it some initialization value. That's the starting value for it, and usually we'll set something equal to 0 just to have some value in that location. Alright, so we have different variable types we can use. We have local variables. Those are going to exist throughout the duration of a particular method or procedure, so a small section of code. So if I have a section of code that's responsible for performing an action when a user clicks on a button, we will declare variables inside of that little section of code, and then while that section of code is running, this variable exists. We also have what are called global variables. Now a global variable would be one that exists throughout the duration of a particular class. And in the way that C# works is typically a class is going to be a file. So if I have a file that contains a section of code, it will have its own variables. And if it's global, that means any section of code that's within that program or inside of that file can reference that memory location. If I make a local variable, only the little method in the section of code that actually references it has access to it. So then we also have super global variables, and what these are variables that will exist throughout the duration of the entire program, and all of the files that comprise the program they will all have access to that variable location. Then we have things that act kind of like a variable when we write them in our code, but they're not variables. They're called constants. And what a constant is I want to declare that our sales tax rate is 0.06. Well, if I declare that sales tax rate, then throughout the life of my program, that location should never change again, or that value should not change. So typically what I'll do is I'll declare that as a constant, so that way somebody cannot programmatically change the sales tax rate. Now, there's a difference between what's called a constant and a read-only memory location. A constant is one that when I compile the program, when I actually build an executable file, that it gets hard-coded into the executable and there's no way to change it. A read-only is one that gets, the value gets evaluated every time the program runs. Now, the benefit to a read-only value is that I could look in the registry, or I could look at another file like an INI file, I could look in a DLL, I could ask the user for the initial value, and what will happen is throughout the entire time that the program runs, that memory location cannot change. But the next time that we run the program, there's a possibility that that value changes. So a constant, when I build the executable, it will never change. A read-only, when I run the executable, it will not change until I quit the program and start it again. Alright, so then we have these things called instance variables, and what this is going to be everything that I create, everything, has to have a name. And so what I'm going to do is I'm going to declare, let's say I bring up the calculator for Windows. Well, what will happen is the system will actually provide a section of memory that allocates all of the resources that are required by that calculator. And the calculator has things like a form, and it has buttons, and it has a text box for displaying the output. So what I need to do is I need to specify that I'm making a new button. And every time I make a new button, I have to give it a name. So those are called instance variables. So when the program's running, this button exists. This button is an object on my form, and it has a memory location. Here's what the name of that location is. All right, so an example, this would be if I make a new form to hold a person's account information, or if I want to create a random number, we have to give those a named memory location. So we're actually going to reference these as what's called an instance variable. I simply give them a name. When I give it a name, it gets loaded into memory, and then we can reference that object by its name. Alright, so there's this thing called scope. Now what scope is, it's going to be how long does my variable actually last? How long does it exist? Now in most of our programs, the scope of a variable will be very small, which means that it only gets created when I need it, and then when it's done being used, it usually goes away. Alright, so if I have a local scope, if I have a variable with local scope, that means that whatever method or whatever little section of code created that variable will automatically create the variable, and then when that little section of code is done running, the variable goes away. The process of it going away is called deconstruction, and then what happens is the computer will do what's called garbage collection, and the garbage collection will actually go through and clear out that memory location. What it actually does is it leaves the value of that memory location, but it takes out the name. So as far as the system is concerned, that name no longer exists, so it can't find the value for that location anymore. Then what we have are called global or static scope, and this is going to be almost all of our methods and objects within a namespace. We will talk more about what a namespace is, but what you need to know is that if I create a global variable, that variable will exist for the entire duration of the executable. And then all other objects and methods that we have are able to directly manipulate or call that value by its name. Now, in reality, what we need to do is we need to create variables, and they should only have as much access as is really needed. So what I'm going to do is I have to specify the scope by deciding where to declare the variable. Do I want it to be available to all of the executables that make up our program? Do I want it to only be available to this one executable, or do I want it to only be available to this one small section of code? So I want to try to make it as limited as possible, but then I also need to prevent other people from being able to talk to my variables. Alright, so we have these things called modifiers, and these are accessibility modifiers. So is my variable public? Can other sections of code look at the value for my variable? Can other sections of code change the value? Can they delete the value? I also have what are called private modifiers, and what this will do is if I have a small section of code, I have a little method that's responsible for creating a variable, adding a value to it, making changes to that variable. Then if it's private, then only that particular method is allowed to interact with it. So what we're doing is we're kind of keeping everybody else out of the value for that particular location. Then we have internal, and what this means is that if I have a small section of code and it turns around and it calls another section of code to perform a task, then we also allow that little section of code to have access to some of these variables. And then we have what are called protected modifiers, and this is going to be anytime I have a child class. So let's say I bring up a form and my form has a button that I click on and another form appears, then what that would do is it would allow that second form to actually be allowed to see the variables that were contained by the first form. Alright, so then we have data types. So the data type is when we declare a variable, we have to tell the system what kind of data is going to be stored in that memory location. The most common types are going to be strings, which are going to be textual data. These are typically something that you're going to type on a keyboard. It could be just simply two sets of double quotes, which means that there's nothing there. But what we can do is we can specify that it is text. It'll typically be, like I said, something that you can type on a keyboard. Integers are going to be whole numbers. We have floats, which are a floating point number. Now what a floating point number is, this is a decimal point number. But there's a difference between a float, a double, and a decimal. They all contain a decimal point. But the big difference is that if I have a floating point number, it actually has two memory locations. It has one memory location to hold the integer portion of the value, and then it has another memory location to hold the decimal portion of the value. So if a float has two memory locations. One makes up the whole number part, one makes up the fraction part. A double is the same thing as a float, but it allows for twice the size of the number. So I can actually have much bigger numbers. I can have more precision with my decimal places. And then we also do have decimals, but usually we use the decimals for things like money, because by default a decimal will typically have two decimal places. It's really easy to format with a dollar sign. So we have these options. Typically what you'll see used though are going to be doubles, and then decimals will be used if we're talking about money. Alright, so then we have different types of what's called casing. So this is how do I type out the name for my variable. Alright, so we have different standards for how to name things. Microsoft has a standard. All the different companies out there have different standards on how to name them. So it's really going to be up to whatever company you're working for. But what we try to do is we try to standardize some things to make it where if I'm working on a program and then you need to come look at the code, you can try to figure out what things are variables, what things are methods, what things are constants, and so forth. And the way that we do that is how we actually type the names for these. Alright, so we're going to use these things called lower camel casing and upper camel casing. Lower camel casing means that the first letter of the first word is lowercase, but the first letter of every other word that makes up my variable name would be uppercase. So in this case, if I have a variable called num item price, the n is a lowercase n. There are no spaces, no underscores or anything like that, and in each additional word has a first letter that is capitalized. So the first letter of the first word is lowercase. The first letter of every other word is uppercase. This typically means that this is a variable. Alright, so then we have methods and classes. Then we use what's called upper camel casing, which is also known as Pascal casing. And the difference is that every single word that we use to make up our name has a first letter that is capitalized. So in this case, if I look at this and I say calculate sales tax, you'll see that the C, the S, and the T are capitalized. And what I can do is I can look at this and say, okay, well that's lower camel case, so therefore this must be a variable. And this is upper camel case, so it must be some sort of class or method or object. It just makes it a little bit easier to figure out what things are variables and then what things are objects. Then we have constants. Now our constants and our read-onlys will typically do with all capital letters, everything uppercase, and instead of spaces we'll put underscores. So in this case we have a sales tax rate, so all caps sales, and then an underscore, tax, underscore, and then rate. And then what this is going to do is anybody that looks at our code will say, oh hey, that's all caps, so therefore it must be a constant or a read-only value. So once again, C# is strongly typed. We have to specify what the data type is. Any variables that we use have to be declared, and we should initialize them, which means we need to provide some initial value for it. Especially if we're going to do things like loops and selection statements and things of that nature. It needs to have some sort of initial value, or else our program won't even compile. The data type must be specified. So whenever I create a new variable, I'm going to not only give it a name, but I also have to specify what the type is for it. Once I declare the data type, it cannot be changed. So in here, this example, we have a double data type that we gave a name to it of some number. Now notice it's lower camel case, so the lower s and then the capital N. So we declare the variable here, and then we set it equal to something, so we initialize it. We give it some initial value. So create a new double data type, call it some number, and then set it equal to 35. So we declare it over here, and we initialize it over here. All right, so then we have this thing called the namespace. Now the namespace is just simply the entire amount of memory, all of the resources that we actually need to make up our program, they all get loaded into memory. And then what we do is we give all of this a name. And the reason for this is it's possible that two separate programs may have the same method names, or two separate programs may have the same variable names, or two separate programs may have the same objects or classes or whatever else. And so what we can do is we can differentiate them by fully qualifying the name for them. And the way that we do that is we reference it as the name of the program, or the name of the namespace, dot, and then whatever the item is that we want to reference. So in this case, it's possible for us to have program1.int number 1, and then we could also have an int number 1 here for program 2. Now this says int number 2, but imagine if this said int number 1, how would we tell the difference between int number 1 in program 1 and program 2? Well, the way that we tell the difference is by fully qualifying it. So we say program1.int number 1, and then program2.int number 1. In this lesson, you learned about the semantics of C#, what a variable is and how it is used in C#. You learned about some of the types of variables that we can use. You learned that an instance name is just simply giving a name to every object that we create. That we have class, static, and local variables. You learned about the data types that we can use for our variables. You learned about the variable casing, such as lower camel case, upper camel case, and then all caps for constants and read-onlys. How to declare and use a variable, how to provide initial assignment to a variable, and then also what the namespace is.